So this video I'm going to do two problems on reflections or translations. These are number 1 and number 7 in your packet that you're doing for homework / whatever. All right, so if I'm going to do whatever this transformation is, I'm going to be thinking I'm going to take the b, the y, and the m points, and then I'm going to do negative y comma negative x with the points. So just for fun, I'm going to write down the b point presently is -4 comma -3. Okay, so its reflective point, I don't know if it's actually its image. So the pre-image is -4 comma 3. Its image, which would be b prime, would be take the y term and negate it. So -3 negated would be a +3. Take the x term and negate it, and that would be 4. All right, if I'm going to do the same thing with the y, the image of the y is -4 comma -1, or sorry, the pre-image of the y is -4 -1. The image is going to be take the y and negate it, which would be 1. Take the x and negate it, which is 4. So the image is going to be 1 comma 4. And then if I take the, let's see, what do we got left? M point, the pre-image was 2 comma -3. Its image, which would be M prime, would be take the y and negate it. So 3, take the x and negate it, -2. Okay, so I can plot those points, and then I'll draw my diagram at least, and then we'll talk about what just happened. So 3, 4 is my b prime. 1, 4 is my y prime. And then 3, 2. 3, -2, right? 3, -2, yep, is my m prime. Connect those dots with a steady hand that I don't have right now, apparently. And that is the image of that shape. So clearly it is not a reflection, because I cannot think of what, well, no, actually, clearly it is not a translation. But it is a reflection. What it is a reflection over, it's a reflection over the origin, because the x and the y flipped and negated, and that's usually the origin idea. So it's a reflection over the origin. If you go back to your guided notes, you'll see that we did like a quick section where we talked about how did the points change, and that would have been the third one on that sheet, where it said that the points were negated each other and flipped each other when it's a reflection over the origin. Okay. Just to mention this shape also has isometry, which means that its shape and size did not change, so it has isometry. So for this problem, this is number 7 in your packet. For this problem, we're to determine if it's a reflection or a translation, and then we're going to write the rule. So when I look at this, my head says it's not a reflection, because I can't see anywhere where it would flip and land the same exact way. So it looks like it's a translation, which means it's slid. So it looks like it's slid this way to get a translation. So now if I want to figure out the translation, I want to look at the D and then the D, and then the D prime, because I'm going from the top image to the bottom image, because I'm going, this is the pre-image, and then this is going to be the image. So if I have D is right here, let me see, I can figure out for the X to get to this D, I went over 1. So, and I went the negative direction 1. So I would say I subtracted 1. And to get to the Y, I went down 1, 2, 3, 4. So there it's going to leave me with, the idea is that I'm going to say my rule would be X minus 1, comma, I don't probably need those parentheses, sorry, I will fix this in a sec. And then I would have y minus 4. So I don't need this parentheses. And that would be my rule. We said that it was a translation and we slid it. Okay, so the idea is I want to find my translation, so I went over 1. So that's why I said x minus 1. And then I went down 1, 2, 3, 4 to get to there. And if I were to check all my other points, that same thing should happen. So if I look at the A's real quick, so the A's, I can clearly see I went over 1, and then I went down 1, 2, 3, 4 also. So that does match up for at least those two. So it should match up for all of it. So that's how I would show a rule. And it's a translation. It also has isometry. Translations always also have isometry. Their shape and their size don't change. That's it.